Hello students, welcome back to your physics online session. Now today let us first of all recall what we did in our last two classes. I hope you all remember that first of all we discussed about matter, right? Then elements, what are elements? Then atom, what are atom? Okay, and then molecule. And after this we studied and read about three states of matter, that are solid, liquid and gases, and the molecules, arrangement of molecules in these states of matter, right? Now today we are going to begin with characteristics of these three states of matter: solid, liquid and gases. Let us get started with it. Each state of matter possesses characteristics of its own. These are as discussed below. It means each matter, whether it is solid or liquid or gas, they have their own characteristics. First of all, let us study about solid. All solids show the following characteristics. First one is solids are rigid and incompressible. It means they are hard and we cannot compress them, right? Then second one is solids have fixed shape and definite volume. They have fixed shape and definite volume. Then third one is solids have their melting and boiling point above room temperature. It means their melting point and boiling points are not normal temperature. The boiling point and melting point is above room temperature, above normal temperature. Okay, now we will move on to liquids. All liquids show the following characteristics. Let us read the characteristics of liquids. Liquids are almost incompressible but less incompressible than solid. It means liquids are also incompressible. We cannot compress it, but they are less incompressible than solids, because solids are very hard, so we cannot compress solid. But in some cases liquids can be sometimes compressed. It means they are less incompressible than solids. Like example I am giving, if I'll fill liquid in a balloon, so I can easily compress the balloon, I can easily change the shape of the balloon, right? Now second point is liquids have fixed volume but no fixed shape. Liquid volume is fixed but their shape is not fixed. As I have told it earlier, that a liquid takes the shape of whatever container we will pour it in, right? If I'll pour the liquid in a glass, it will take the shape of a glass, and if I'll pour the liquid in a bowl, then it will take the shape of a bowl, or it will also take the shape of a plate if I'll pour the liquid in a plate, right? Now third point, liquids flow from higher to lower level. It is correct, because if I'll pour the water from high to low point, we can easily throw it, right? But we cannot take the liquid from low to high level easily. Now fourth point is liquids have their melting points below room temperature and boiling points above room temperature under normal conditions. Now let us see what does this point saying. Liquid's melting point is below room temperature. It means we can melt the liquid below room temperature, and boiling point is above room temperature. It means we have to increase the room temperature, the normal temperature we have to increase, then only we can boil the liquid, and then we can, the melting point has to be below room temperature. It means less than room temperature, then only we can melt the liquids. Okay, now let us move on to gases. All gases show the following characteristics. Gases are highly compressible. In example, gases can be compressed easily by applying pressure. If we have a gas with us, right, so we can easily compress it. And let me take an example of this. If I'll fill the gas or the air in a balloon, right, so it will blow up, right, and then we can compress it easily. We can compress the balloon very easily. So this is what this point is trying to tell us. Now second point is gases have no fixed volume and shape. Gases fill the container of any size and shape completely. Gases don't have any fixed volume and they don't have any fixed shape. They just fill the container or anything in which we will fill the gas, and they will take the size and they will take the shape of that container or of that thing. Now third point is gases can diffuse into each other rapidly. They can mix up into each other very easily. Now gases have their melting and boiling point above room temperature. The melting point and boiling point of gases are below room temperature. Okay, the room temperature has to be low, less than the temperature has to be less than room temperature for melting and boiling points of gases. Now we will move on to point number 1.4, that is properties of solids and liquids and gases. First of all, let us begin with solids. Solid molecules are tightly packed to each other and they are packed close together. I hope you all remember this figure. The molecules in solid are tightly packed, right? Are tightly packed to each other and they are packed close together. The molecules are tightly packed and very close to each other. Okay, this is what happens in the arrangement of molecules in solid. Now the molecules in a solid have a greater attraction to each other than to those in liquid or gases. The molecules were arranged very closely, so the attraction between them was greater than that of solid or liquid or gas. Now solids have definite shape, size and hardness. Yes, we all know that solids, all the things that are of solid are hard. We can see this pen. This pen is very hard and it will take me lot of hard work to break this pen, right? Then solids have definite size, shape, hardness, texture and color. They have their specific texture and color. All these properties are used to describe the solids. So all the properties like definite size, shape, hardness, texture and color are used to describe the solids. Now solids have a certain boiling point, melting point and density. Most of the physical properties of solids are easy to identify and describe. These properties are used to identify the solids. Now we can see that solids have a specific boiling point, melting point and their density. And most of the physical properties of solids are easy to identify and describe. Now these are the physical properties, definite size, shape, hardness, texture and color. Now these properties are used to identify the solids. Now if we have to identify any solid, we actually used to see these physical properties. Then only we can easily identify whether it is a solid or not. Now let us move on to liquids. The properties of liquids are easy to observe and describe. The attractive and repulsive force between the particles in a liquid is comparatively less than solid. These forces are inversely related to the distance between the particles. Now properties of liquids are easy to observe and describe. Now we will see the properties, and they are saying that they are very easy and easy to observe and to describe whether it is a solid or not. Now the attractive and repulsive force between the particles in a liquid is comparatively less than the solid. Now we can see here that the molecules are arranged in such a way that they are a bit far than each other, right? So what, let us see the repulsive force. The repulsive force is less because they have enough space between them. Okay, so they don't have repulsive force in it, and these forces are inversely related to the distance between the particles. As they have enough distance between them, so that is why they don't have much repulsive force between them, right? In liquids, the particles are very close to one another, and the intermolecular attractions in a liquid are strong enough to affect its physical properties. Liquid particles are touchingly close to uh, one another. Since the strong force between liquid particles hold them together, the volume of the liquid is constant. In liquid, the volume is constant, and because the force between them hold them together, the force that is there between them hold them together, so that is why volume is constant. The given number of liquid particles will occupy a much smaller volume than the same number of particles as others. At the boiling point of liquid particles, the force of attraction that holds the particle is overcome, and liquid particles start transferring to the gaseous particles. When we boil the liquid, I hope you all have seen seen when we boil the liquid, they become in gaseous state. Matlab, the vapor that comes out of the container is the gaseous state of the liquid. So how does it happen? The force of attraction that holds a particle is overcome. The force is overcome, and the liquid particles start transferring to gaseous particles. The force that is there between them starts leaving it. So that is why after it becomes, or it get converted to gaseous particles. But if the stick togetherness is high, then it takes more motion to separate the particles within the liquid where boiling occurs. The flow of liquid depends on the viscosity of the liquid. The thickness of the liquid. The flow of liquid depends on the viscosity of liquid, means on the thickness of the liquid. For example, water flows more easily than syrup, and syrup flows more readily than honey. Examples they are giving to us that if I'll flow a water, it will flow easily, right? But then if we'll compare water and a syrup will liquid will flow easily and syrup will flow in a slow state, right? And then if we'll compare syrup and honey, so honey will flow more slowly than syrup. So this is how the flow of liquid depends on the viscosity of the liquid, on the thickness of the liquid. Now we will move on to gases. Let us read about the properties of gases. Have different set of properties that is totally different from solids and liquids. Let us read about it. Gases do not have definite shape. Now I hope you all remember. Let us come to this diagram again. The molecules arranged in gases are very far from each other, right? And we have studied about that they have great deal of space between them, and they have high kinetic energy, and that is why gases have no shape and no definite volume. So we all know that gases they themselves don't have any shape. Okay, the force of attraction between molecules is very negligible in the case of gases as compared to solids and liquids. The force of attraction among the molecules or between the molecules is almost zero. In case of gases, in the gases, the force of attraction is almost zero or very less. Okay, so the distance between the molecules is much larger as compared to the atomic distance in solids and liquids. Now the distance between the molecules is much larger. They have enough space between them as compared to solids and liquids. Molecules of gases move in straight lines and undergo random collision with other molecules and occupy the complete space available in the container, unlike solids and liquids. Now, the molecules of gas, they move in a straight line and they undergo random collision. They just collide with each other, with other molecules. The molecules are just collide with each other and they occupy the complete space. They have lots of space, they occupy it, and that is available in the container. If I'll fill the gas in a container or in any balloon or in anything, they occupy the full space, okay, because they have enough space with them. It is not like solids or liquids. They have gases, molecules in gases have enough space with them and they occupy the complete space that is available to the container or whatever thing we have filled it in. Okay, so that is all for today, students. Please read page number 12, okay, and gases of page number 13 in for today's class. Okay, then this one we will discuss in our next class. Okay, and if you have any doubt, please feel free to ask it anytime from me. That is all for today. Have a good day, students.